to split apart our variables on this one, I would suggest dividing both sides by 1 plus x squared, multiplying both sides by dx, and dividing both sides by 1 plus y squared, and then let's see what's left over. Looks like we get a y over 1 plus y squared equals x over 1 plus x squared. There's a dy over here and a dx over here. Okay, so that looks good. It gets kind of messy separating those variables at times, so you may not want to do it in one step, but in the end you should get it down here. Okay, so integrating these, neither one of these look that much fun, but we can do u substitution here. So let's work out one of them and then copy our work for the other one. So let's make u be this 1 plus y squared. So du would be 2y dy, but I want 1y dy. So divide this side by 2, divide this side by 2. So this is the same thing as 1/2 integrating 1 over u du, or 1/2 natural log absolute value of u and then plus c. But this guy is going to work out the same way, so I get to just cheat and copy my work, and then let's not forget to include rc here as well. So the textbook does kind of a weird trick where they say if you want your work to match up with what they did, they're saying if this is an unknown number, then we can also just call it like an unknown number inside of a natural log. It's still an unknown number, and then you can use properties of logarithms to combine those. But let's see if we can not take that approach, because I don't think that's not something that I would quickly think of doing. So since I've now integrated, I would probably just plug in my initial condition and see where that gets me as far as finding c. So plugging in 0 for x and square root of 3 for y, get to here. So this would be 1/2 natural log of 4 equals 1/2 times natural log of 1. Natural log of 1 is 0 though, so looks like C1 is 1/2 natural log of 4. So I'm going to take this line and then plug it back in. Okay, so then that gets us to this. Okay, so now trying to solve this guy for y, let's just go ahead and multiply everything by 2. That will get rid of a lot of our messy fraction work. And then let's exponentiate, put both of these to an exponent of e. So e to the natural log, to the log base e of this stuff is going to end up being this stuff. Over here, I need to split these up first. Remember, multiplying things with the same base is like adding the exponents. It's just that we're now trying to go this direction, split them apart. And so now e to the log base e of this stuff should just come out to be that stuff. And then over here we can simplify this to just be 4, for the same reason that this became this and that became that. E to the log base e of 4 should just be 4. So let's multiply that by 4. And okay, so I took a little different path than what the online textbook did, but now I'm in the same location. I just think that the trick that they did with the natural log halfway through an unknown number is just not something that most people are going to think of. But there we go.